The patents in suit are primarily directed to lighting systems attached to cameras used in the motion picture and television industries. Proper illumination is necessary when filming feature films, television shows, or commercials, whether such activities are carried out indoors or outdoors. A primary purpose of a lighting system is to illuminate a subject to allow proper image capture or achieve a desired effect. Often, it is desirable to obtain even lighting that minimizes shadows on or across the subject. It may be necessary or desired to obtain lighting that has a certain tone, warmth, or intensity. It may also be necessary or desired to have certain lighting effects such as colorized lighting, strobed lighting, gradually brightening or dimming illumination, or different intensity illumination in the fields of view. Some of the challenges to providing proper lighting for film and video include generating sufficient light intensity to illuminate a subject or set, creating proper lighting quality and tone or warmth for quality or artistic reasons, matching the color or hue of the light to the appropriate film stock and conditions, providing even illumination over the area of interest which is also portable so as to work on a moving camera system, controlling the light in a convenient and predictable way, or providing lighting effects for the film or video sequence, making the lighting maneuverable and easily ported because the scene or camera angle may move in real time during filming, versatility for use in different settings to provide proper illumination in both indoor and outdoor settings. Lighting for television and film is obviously much more complicated than simply flipping a light switch. As one example, it can be quite challenging to provide proper illumination for the lighting of faces in television and film, especially for situations where the camera is near the subject. Often, certain parts of the face must be seen clearly. The eyes, in particular, can provide a challenge for proper lighting. Light reflected in the eyes is known as eye lights or catch lights. Without enough reflected light, the eyes may seem dull. A substantial amount of effort has been expended in constructing lighting systems that have the proper directivity, intensity, tone, and other characteristics to result in aesthetically pleasing eye lights, while also meeting other lighting requirements and without adversely impacting lighting of other features. Film has been around for 100 years and video for several decades. And for all this time, good film lighting has been desired. There are many different types of bulbs used in the film industry, each having very specific characteristics, and they have been used in many different configurations. Interestingly, this is one of the few industries that uses equipment that is virtually identical to what it was 50 years ago. Because of the varied settings in which lighting systems are used, the conventional practice in the film, commercial, and related industries is for a lighting system, when needed, to be custom designed for each shoot. This practice allows the lighting technician to have available a system that is of necessary size and that provides the desired intensity, warmth, tone, and effects. Designing and building customized lighting systems, however, is often an expensive and time-consuming process. The most common lighting systems in film, commercial, and photographic settings use either incandescent, HMI, or fluorescent bulbs. However, these conventional lighting systems have drawbacks or limitations which can limit their flexibility or effectiveness. Incandescent bulbs use a filament inside a sealed glass globe. They generally provide good quality light for film and television and have been a mainstay for many decades. The quality of the light is matched well for tungsten film, and they can be made very bright. However, despite their widespread use, incandescent-based lighting systems have several disadvantages. A major drawback of incandescent lighting systems is the amount of heat generated by the incandescent bulbs. Because of the heat intensity, subjects cannot be approached too closely without causing discomfort to the subject and possibly affecting the subject's makeup or appearance. Incandescent lighting may cause undesired side effects when filming, particularly when the intensity level is adjusted. As the intensity level of the incandescent lights change, their hue changes as well. Film is especially sensitive to these changes in hue, significantly more so than the human eye. In addition, mounting frames used in incandescent lighting systems are often large and ponderous, making them difficult to move around and otherwise work with. Incandescent lighting systems also consume a lot of power, especially for larger lighting systems, which may be needed to provide significant illumination. They also generally may require a wall outlet or other external power source. Fluorescent lighting systems generate much less heat than incandescent lighting systems, but nevertheless have their own drawbacks or limitations. For example, fluorescent lighting systems, like incandescent lighting systems, are often large and cumbersome. Fluorescent bulbs are generally tube-shaped, which can limit the lighting configuration or mounting options. A major drawback with fluorescent lighting systems is that the low lighting levels can be difficult or impossible to achieve due to the nature of fluorescent lights. When fluorescent lights are dimmed, they eventually begin to flicker or go out as the supplied energy reaches the excitation threshold of the gases in the fluorescent tubes. Consequently, fluorescent lights cannot be dimmed beyond a certain level, greatly limiting their flexibility. In addition, fluorescent lights suffer from the same problem as incandescent lights when their intensity level is changed. That is, they tend to change in hue as the intensity changes, and film is very sensitive to alterations in lighting hue. Another lighting system used in the motion picture and video industries is commonly referred to as HMI. HMI systems also generate much less heat than incandescent lighting systems, but also suffer from changes in hue as the intensity levels are adjusted. Typically, incandescent, HMI, or fluorescent lighting systems are designed to be placed off to the side of the camera. Because of such positioning, lighting systems may provide uneven or off-center lighting, which can be undesirable in certain circumstances. Because of their custom nature, both incandescent lighting systems and fluorescent lighting systems can be difficult to adapt to different or changing needs of a particular film project or shoot. For example, if the director or photographer decides that a different lighting configuration should be used or wants to experiment with different types of lighting, it can be difficult, time-consuming, and inconvenient to rework or modify the customized lighting setups to provide the desired effects. In recent years, some companies have come out with stage lighting based upon LED technology. LED stands for light emitting diode. LEDs are traditionally small, low-power semiconductor-based lights, most commonly seen in red, green, and blue hues. LED-based lighting systems, developed as lighting effects for live entertainment, such as theaters and clubs, typically include a combination of colorized LEDs in hues such as red, green, and blue. In other words, an RGB combination. This RGB combination can be combined to give the impression of white light. But these types of lighting systems are not well suited for applications requiring more precision primary lighting, such as film, television, and video. Among other things, the combination of red, green, and blue or other colors creates an uneven lighting effect that would generally be unsuitable for most film, television, or photographic applications. Moreover, many of these RGB-based lighting apparatuses suffer from a number of other drawbacks, such as requiring expensive, inefficient power supplies, incompatibility with traditional AC dimmers, lack of ripple protection when connected directly to an AC power supply, unpredictable color temperatures, and lack of thermal dissipation. LEDs have also been used in automated machine inspection systems. These LED-based lighting systems are also generally not suitable for the movie, film, or photographic industries. Such machine vision systems compare still frames against a reference image in order to further align the placement of electronic parts, wherein the light is directed to illuminate a small area only a few inches away from the source. These systems do not have the same requirements of film or video for providing tone, warmth, or intensity suitable for film or video, or for lighting a wide area, or for being portable, or for being adaptable to indoor or outdoor conditions, and so on. The three patents in suit address these problems in the art in a variety of ways. The inventions provide various lighting systems that are generally lightweight, portable, and power efficient, while at the same time being capable of lighting a wide area in a manner compatible with the needs of film, television, and video. All of the patents relate to lighting devices that can be readily attached to and detached from movie cameras and the like. The invention of the 310 patent generally relates to a lightweight, portable, and versatile camera-mounted wide-area LED lighting device. A preferred embodiment has a flat ring-shaped frame or panel with a hole in the middle and arrays of LEDs arranged in concentric circles. A mounting bracket and clamp are used to allow attachment of the light panel to various types of movie cameras. The patent describes the use of special daylight-colored LEDs. The number and arrangement of LEDs is sufficient to provide light over a wide area, and the symmetrical arrangement provides evenness of lighting. The end result is a lightweight, portable camera-mounted LED lighting device that outputs high-quality light for movie or film applications and is adaptable to different camera types. The 823 patent builds upon the concepts and innovations of the 310 patent. One of the issues that comes up when building an LED-based lighting device for movie or film uses is that the number of LEDs can be quite large to illuminate a large area. This can result in a lot of manual labor to build a lighting device, and also can result in a lot of heat being generated as more LEDs are placed close together. The inventors of the 823 patent address these problems by creating a lighting device that, like the 310 patent, is based on a lightweight, portable frame or panel that is adapted for being readily attached to and disengaged from a movable camera. But in this case, it specifically uses surface mount light elements and a heat dissipation system that allows more concentrated use of LEDs, thus enabling illumination of a wide area with a sufficient number of LEDs. The design of the 823 patent allows more stable, constant temperature during use, which is important for film applications. The invention of the 302 patent relates to another variation or improvement upon the same general type of camera-mounted lighting device described in the first two patents. Like the 823 patent, the 302 patent device involves a lightweight, portable frame or panel that is adapted for being readily attached to and disengaged from a movable camera, and surface mount light elements with a heat dissipation system that allows more concentrated use of LEDs. In the 302 patent, the surface mount LEDs are specifically daylight or tungsten color, which thus makes the light more compatible with the needs of movie or film lighting. The lighting device of the 302 patent also includes a focusing element for altering the focus or direction of the light emitted by one or more surface mount semiconductor light elements, thus giving an added layer of control over the light being generated.